Good morning, students. Myself, Vijay Shankar from Electronics and Communication Engineering Department, Chippewa Engineering College. Today, we are going to discuss about the inverse Fourier transform examples. From last 3 days onwards, we are discussing about the examples of Fourier transform and the inverse Fourier transform. Got different types of examples. In the last class, we missed the last part of this Fourier transformation of the triangular wave. We already find out the equation of the line x of t is equal to equation of the line p x of t is equal to, and how we got this a into t by t plus 1, and it is multiplied with the step function, advanced signal with the time period t, and it is subtracted with the step function. And the second term also, the mu of t minus mu of t minus capital T. And convert into the ramp function, the ramp function r of t plus capital T minus 2r of t plus r of t minus t. Okay. So we got two expressions, a by t of L, simplifying why we are taking the t plus t and the mu of t. The mu of t Fourier transformation, mu of t Fourier transformation is 1 by j omega. Okay, t into mu of t, the Fourier transformation 1 by j omega whole square, and this t into mu of ramp function r of t is equal to t into mu of t. Okay, and r of t plus capital T, the Fourier transformation e power, because it is a minus, e power j omega t 1 by j omega whole square. So I got the time shift property. The time is shifted. The r of t is the t into mu of t. It is a Fourier transformation 1 by j omega whole square. Because it is shifted with the t samples, advanced samples, nothing but t of t minus of minus. So e power minus j omega minus t, nothing but e power j omega t1. Since it is r of t minus t, its Fourier transformation is Fourier transformation. Now it is a e power minus j omega t 1 by j omega whole square. Okay, my dear students. Got to remember this, all the Fourier transformation relations. You see the first one, the x of t. After simplifying the equation, we got x of t is equal to a by capital T whole multiplied with r of t plus capital T and minus 2r of t and plus r of t minus t. Again, apply the Fourier transformation on both sides. X of t becomes x of omega. So a of t is a constant. And see the r of t plus small t plus capital T, the Fourier transformation, see here, e power j omega t 1 by j omega whole square. E power j omega t. Because it is shifted with the minus t samples, and t into mu of t, nothing but r of t Fourier transformation is 1 by j omega whole square. Okay, minus if the 2 is there, what is the Fourier transformation of r of t? R of t is a t into mu of t, nothing but 1 by j omega whole square. 1 by j omega whole square plus, and the last one you can see the r of t minus t. So the e power minus j omega the t. Here it is a minus of minus t minus t. So it is a minus of minus, it becomes here the plus. So e power minus j omega t 1 by j omega whole square. Okay. See, we got the same thing here. The x of j omega is equal to e by t, e power j omega t whole divided by j omega whole square minus 2 into 1 by j omega whole square plus e power minus j omega t j omega whole square. It's a very, very, very important matter, students. Okay. So what is the Fourier transformation of, determine the Fourier transform of the triangle function. So simple, they given like this, the minus t to the t, the triangle function with the t variable and the x of t. So first of all, you can find out the line equation of A here and the line equation of B with the quadrants minus t0, 0a and t0 by using the formula y is equal to mx plus c. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1, where y is the x of t here, where y is the x of t and x is the t value and remaining the quadrants x1 y1 and the x2 y2. In the x-axis x1 y1, x1 x2, not the x1 y1, my dear student, sorry, x1 x2, and the y-axis y1 and y2. One time you can take these two quadrants to find the line equation of A, and one other time you can take these two quadrants to find the line equation of the B. Then after it is multiplied with the step functions. The step function look like the ramp, they given the triangle wave like this, and the first for this slope of the line equation of A, we need a step function like this, and for the line equation of B, it requires the step function 0 to minus t it is, and here the 0 to t. Okay, to get these gated equations, the mu of t minus t for this, and here the mu of t plus t minus mu of t to get this gated equation or the gate pulse. Understood? Multiplying the two functions of A and this gate function and multiplying the B and this gated function to get x of t is equal to A by t, the t plus t, and multiplication of top step functions A by t into t minus t, the multiplication factor of the step functions. All my dear students, so very, very, very important triangular function and the rectangular function also. We already seen the rectangular function. Okay, yesterday we missed up to here due to the technical problem. Come to the next one. Applications of Fourier transform of network analysis. So we already know the network analysis for the second year students don't know, and the triple E students, they are well known because they are triple E. The network here the given it is determine the voltage V out. The applications of Fourier transform of network analysis. Determine the V out of t is a signal to a current source excitation I of t is equal to e power minus t mu of t. So given the current signal I of t, that is e power minus at mu of t, how to find out the p of v out of t from the circuit diagram. Okay, you know, my dear students, the current signal I of t is equal to whatever the I1 current and the I2 current is passes, and the output voltage V out is equal to across the capacitor here. And total current equation is equal to I is equal to I1 plus I2. In terms of the voltage, I of t is equal to the current that is passes through the resistance is V by I. V by I. Is a V out by I. Okay, not the V by I, V by R, my dear student, because we are taking that is a V is equal to IR. Okay, V is equal to IR means R is equal to V by I. Okay, so V out, sorry, what I am saying, it is I1 of t, the current that is passes through this resistance, the current that is passes through the resistance I is equal to V by R. Saying always it is a V by I, sorry, V by R. I is equal to V by R. V is equal to IR and I is equal to V by R. Okay, my dear students. What is the V here? The V out. V out of t taking as a time domain signal, and R we can see the 1 ohms. 1. So V out of t by 1, and this is I1, my dear students. And I2 current here. I2 is also across the capacitor. Across the capacitor. You see, across the capacitor, I is equal to C into dV by the dt. C into dV out of t by dt. Okay, my dear students. But in terms of the voltage is a 1 by C the integral I into dt. But here you are applying the I2. So I of t is equal to V naught of t by 1 plus, and the C into, what is the C? C here the 1 by 2, my dear students. That is equal to 1 by 2 into d V out of t by the t dt. Okay, my dear students, these are the two currents as the I of t is given. The I of t is equal to V out of t by 1 plus 1 by 2 into d by the dt of V out of t, my dear students. Okay, after substituting. So what is the given of I of t? E power minus t mu of t. E power minus t mu of t is equal to, this is the equation, V out of t plus 1 by 2 d by dt of V out of t. Now you can apply the Fourier transformation on both sides. Fourier transformation. This is application of the Fourier transform of the network analysis. Given the time domain signal, we are converting the network given in terms of the time domain function equations. What is the Fourier transformation of e power minus t mu of t? Actually, we know the e power minus at mu of t. E power minus at mu of t, the Fourier transformation is 1 by a plus j omega. Okay, 1 by a plus j omega. Instead of a, here it is a 1. So what is the Fourier transformation? 1 by 1 plus j omega. Follow my dear students. Here the 1 is there. Is equal to V out of t. So x of t. What is the x of t? The Fourier transformation, the time domain function x of omega. Fourier transformation is x of omega. Instead of x, here the v. So v out of t into omega. V out of omega plus 1 by 2 into another property here, the d by dt of mu of t, saying that it's a time differentiation property. According to the time differentiation property, the d by dt of x of t, what is the Fourier transformation, my dear students? Is one of the property we already know. It's j omega into x of omega. Okay, the derivative of the input signal x of t. Here instead of x of t, the v out of t here. So j omega into v out of omega. Okay, my dear friends. So take the common of v out of omega is equal, not is equal to, whole multiplied with 1 plus j omega by 2. Okay, my dear students. J omega by 2. Fine. Now the v out of omega is equal to, we need the finally the v out, the Fourier transformation of the v out of omega is equal to, already we have the 1 by j omega, and you can cross multiply this function by taking off 2 whole divided by the 2 plus j omega. Here take it as a common, the 2, take the LCM, 2 plus j omega, and 2 will in the numerator. 2 by 1 plus j omega. Okay, here the 1 plus j omega is there, and 2 plus j omega will get here. 2 plus j omega. Follow my dear students. Okay. Now, we already seen how we can find out the inverse Fourier transformation. Inverse Fourier transformation is Fourier frequency domain function is converted into the time domain function. How? By using either it is a convolution property or by using the method. Okay, here convert this into partial differentiation method, my dear students. Okay, I will explain the whiteboard. See, we got the x, v out of omega is equal to 2 by 1 plus j omega and 2 plus j omega. Okay. So v out of omega is equal to 2 by 1 plus j omega and 2 plus j omega. Okay, this is the equation we got, my dear students. We need to find the v out of t. So apply inverse Fourier transformation on both sides. So before that, see, first of all, you can use partial differentiation method, a by 1 plus j omega plus b by 2 plus j omega. Okay, my dear students. Find the a and b values. So 2 is equal to a into 2 plus j omega plus b into 1 plus j omega. Now I can take the two equations comparing take the coefficients of j omega. Here there is no any coefficient of j omega on the left hand side. 0 is equal to a into j omega plus b into j omega. So a plus b is equal to 0. And take the constants. What is the constants here? The 2 is equal to 2a plus b. 2a plus b minus students. What is a is equal to minus b, or b is equal to minus a, whatever it is there. So 2 is equal to 2a. Now I am substituting that b is equal to minus a. So 2 is equal to a, my dear students. A is equal to 2, and coming to that, what is a B? Therefore, the B is equal to minus 2. B is equal to minus 2. Now I can substitute B out of T, not the T, omega. B out of omega is equal to A. What is A? 2 by 1 plus j omega, and B is minus 2 by 2 plus j omega. Okay. Now I can see whether it is a right or wrong. The 2, 4 plus j, 2j omega, and minus 2, minus 2j omega. 2j omega, 2j omega cancel, and 4 is already there. 4 minus 2, the 2. Okay. We got it is a right answer. Now we can apply the inverse Fourier transformation. Apply inverse Fourier transform on both sides. Okay, students. What is the inverse Fourier transformation of V out of omega? V out of T. V out of T is equal to, here the 2 is a constant. What is the 1 by 1 plus j omega? E power minus T mu of T. Okay. Actually here it's a A. Instead of A, here the 1. Minus 2 into the 1 by A plus j omega. What is the A here? The 2. E power minus 2t mu of T. Okay, my dear friends. Finally, therefore, V out of T is equal to, either 2 is common, and here also the 2 is common, and the mu of T is also common. The 2 into e power minus T minus e power minus 2t mu of T. Okay, my dear students. For the given network, for the current I of T is equal to e power minus T mu of T, the voltage V out of T is equal to 2 into e power minus T minus e power minus 2t into mu of T. Not the V, my dear student, is a mu step function. Okay. So see what they got here. So V out of T is equal to 2 by 1 plus j omega minus 2 by 2 plus j omega. Whatever it is, the V out of T is equal to 2 into e power minus T mu of T minus 2 into e power minus 2t mu of T. Understood, my dear students? Okay. Then you go for the next one. And these are another example actually. And see, to determine the response of current in the network shown here. In terms of the voltage given, the V of T is equal to, previously it is a current network, now it is a determine the response of current in the network shown in the figure when a voltage having the waveform shown. So given the voltage here, and you have to find out the current. The previously the current is given, you have to find out the voltage from this network. See, for the voltage, they given, it is also a graphical representation, only the waveform simply. The waveform is given, and this waveform you can observe here in the solution. The waveform, the V of T is defined as V of T is equal to, they write at, they wrote it is a sine T mu of T minus mu of T minus pi. The first example we already seen. Today's first example is a triangular wave. The triangular wave line equation we got, but it is multiplied with the step function. Similarly, here the half wave is given. In the half sine wave, I'll explain clearly. Let us see here. So actually it is a sine wave. Up to this is a sine wave. From 0 to pi, and this is a 2 pi. But fully is not given. 0 to pi only we got. So for that function is a sine t, let us say, is a sine t. Now I am taking the step function mu of t from 0 to infinite, the t variables, and we need only the up to 0 to pi only, my dear students, 0 to pi. So now you can shift this sample, the step function, you can shift towards the right side with the pi samples. So mu of t minus pi, here the minus means the delay function, pi. Okay, subtract these two functions, mu of t minus mu of t minus pi. Okay, my dear students, listen carefully. If you are not following means definitely it is difficult to understand. So now I am subtracting these two functions from 0 to pi. Here also let us assume the pi is there. Okay. From 0 to pi, the mu of t minus pi is a 0. And mu of t is a 1. 1 minus 0 is a 1 up to the pi. Okay, my dear students. And here the from pi to infinite and pi to infinite both are 1 only. 1 minus 1 is a 0. Okay. Now you can multiply these two functions. First one is a sine. So v of t is equal to sine t whole multiplied with, you can multiply these two functions. Here see 0 to pi, there is a sine wave is there, positive half cycle. For negative half cycle, see observe here the pi to the infinite is a 0. Is a 1 and is a 0. 0 into this negative half cycle is a 0, and positive half cycle with this one is a positive half cycle. What we got, it is the same thing, the given term. So the mu of t minus mu of t minus pi. Okay, my dear students, the given mu v of t from this diagram, from this waveform, the mathematical equation or the given signal is v of t is equal to sine t mu of t minus mu of t minus pi. Following, my dear students? Okay, by graphical representation only we know the given equation. Understood? So this is a given. I am erasing all these things. Okay, students. So we got the v of t is equal to sine t into mu of t minus mu of t minus pi. Okay. From the given circuit, we have to write the equation. What is the equation here? The v of t is equal to the current is that is passes through the resistance. Already said that is a v is equal to IR. The resistance is 1 and the current is a I1 into I of t plus, and the current that is passes to the capacitor, because we are applying now that is a voltage equation. Previously the current equation. The current equation across the capacitor C into dV by dt. But in terms of the voltage, KVL, Kirchhoff's voltage law, 1 by C into integral I of t dt. Okay, what is the C here? What is the C? 1 farads, and the resistance is 1. So 1 into I of t. So actually the equation is like this, my dear students. V of t is equal to, if this is a resistance, I of R into I of t plus 1 by C the integral I of t dt. This is the actual equation of the applying the KVL for this circuit. What is R here? 1 I of t plus, and what is the C here? 1 by 1 integral I of t dt is a V of t is equal to. Okay, my dear student. What is a V of t? Sin t mu of t minus mu of t minus pi is equal to I of t plus integral of I of t dt. Okay, my dear students. Now, I'm taking here the V of t is equal to V of t, the final equation, the V of t is equal to I of t plus integral of I of t dt. Okay, my dear students. Now, the V of t sine, right here it is a sine t into mu of t minus mu of t minus pi now I of t, listen carefully my dear students, I of t plus the integral I of t dt, integral I of t dt. Now I am taking the Fourier transformation of the Fourier transformation is the left hand side. First of all, you can see the Fourier transformation of the left hand side, my dear students. Sin t mu of t minus mu t minus t minus pi is equal to I of t integral I of t dt. We need here determine the response of the current for the given voltage. We'll explain in the whiteboard, my dear students. So remember this equation sin t mu of t minus mu of t minus pi. This is sin t mu of t minus mu of t minus pi is equal to I of t plus integral I of t dt. Integral I of t dt. Now you can apply the Fourier transform on both sides. Apply Fourier inverse for Fourier transform on it. Okay. Fourier transform on both sides. Fourier transform on both sides. You see here, actually the sin t mu of t, the first one, sin t mu of t minus sin t mu of t minus pi is equal to I of t plus integral I of t dt. See, after applying the Fourier transformation on both sides, sin t mu of t, we already know the sin t mu of t. One of the equation, the sin t is a e power jx sin x. Let us see here, I will write sin x is equal to e power jx minus e power minus jx by 2j, my dear students. Okay, see the sin t. Sin t means e power jt minus e power minus j t by 2j, and it is multiplied with the mu of t. Okay, my dear students, mu of t. Minus, similarly here also you can see the sin t is a e power jt minus e power minus jt by the 2j into mu of t1. First I am finding out this Fourier transformation of this function. 1 by 2j Only I am finding the first term, my dear students. Don't confuse. 1 by 2j e power jt minus e power minus j into t. Apply the Fourier transformation. Fourier transformation function 1 by 2 into e power jt. 1 by 2 into e power jt, my dear students. Or otherwise, without any confusion, you can find out the 1 by 2j. We know the 1 with the Fourier transformation. 1 with the Fourier transformation is 2 pi delta omega. 2 pi delta omega. Okay. 1 with the e power jt. E power jt means it is a shifted function. 2 pi into delta of omega minus t. Okay, my dear friends, minus t. 1 with the e power jt. The mu of t here, it is a mu of t function is also there, the mu of t. If you have any doubt, you can find like this. Otherwise, into mu of t also, mu of t. So, e power jt mu of t minus e power minus jt mu of t. What is the Fourier transformation of this function? X of omega is equal to integral minus infinite to infinite e power j into t mu of t and e power minus j omega into t dt. This is the equation, my dear students. What is the mu of t? 0 to infinite. Okay. So 0 to infinite, you can change the limitations, keeping the mu of t is a 1, e power jt, e power minus j omega t dt. That is equal to integral 0 to infinite e power, bases are same, you can add the powers. Take the common of j, and the t is also common, my dear students. T is also common. 1 minus j omega. J is also there. Sorry. Jt. 1 minus omega. See, e power jt and e power minus j omega t dt. So, what is the Fourier transformation of this function? E power j into 1 minus omega into t whole divided by j 1 minus j omega. If the upper limit is infinite, lower limit is 0. Infinite is becomes of 0. E power 0 is a 1 minus by j into 1 minus omega. Sorry, here there is no any j. Here 1 minus omega 1 minus 1 by j minus 1 by j into 1 minus omega is the first term. First term, my dear students. For the second term also, we'll get minus of minus e power minus. We got here the minus means take the minus as a common. 1 plus j omega. So you'll get for the 0 to infinite again, the minus into minus is a plus. It becomes of for the second term 1 by j into, let us see here. Sorry. This is for the first term, my dear student. For the second term, what is the expression we got? The 0 minus 1 by j into 1 plus omega. 1 plus omega. Here the minus is there, and in this also the term is a minus. Minus into minus plus. So simplifying these functions, minus 1 by j into 1 minus omega plus 1 by j into 1 plus omega. So minus of j into 1 plus omega plus j into 1 minus omega whole divided by, it is a j square 1 minus a plus b into a minus b. A plus b into a minus b means a square minus b square. Okay, my dear friends. So minus j plus j get cancelled. Minus j omega and minus j omega. Minus 2 j omega minus 2 j omega, and here the j square is there, minus 1 into 1 minus omega square. Minus and minus get cancelled, becomes of 2 j omega by 1 minus omega square. For this function to function, 2 j omega by 1 minus omega square. And this function is shifted with the mu of t. So the mu of t is t minus pi. T minus pi. That also you can find out the sine t into mu of t minus pi. According to that, we get the second term Fourier transformation also. Okay, see. For the first term, we got b of j omega is equal to, see the t sine t mu of t, the 1 by 1 plus j omega whole square we got, and Fourier transformation of sine t b of t minus pi e power minus j, because it is shifted with the samples, e power minus j pi omega by omega square plus 1. Okay. So directly, without doing that all the things, my dear students, we know the one of the formula is there. And formula is sine t mu of t. Sine t mu of t is equal to 1 by sine a t actually here. Sine a t a square plus j omega whole square. J omega whole square. What is a here is a 1. So sine t mu of t, it becomes of 1 by 1 plus j omega whole square. Understood, my dear friends? So directly you can write as, and it is shifted with the pi samples, so it is multiplied with the sine t mu of t minus pi. So shifted with the samples means e power minus j omega pi into the same thing, 1 by 1 plus j omega whole square. Okay, use this. So the Fourier transformation of t into this one, Fourier transformation of a sine function in the right hand side, and in the left hand side, not the left hand, it is the left hand side only, my dear students. In the right hand side, you can see the I of t and integral of I of t. Okay, so we got 1 by j omega whole square plus 1 plus e power minus j pi omega whole divided by j omega whole square plus 1 is equal to, what is I of t? I of omega, Fourier transformation. Integral of I of t, I of omega by j omega. So yeah. Integration time, one of the properties. Time differentiation is j omega into I of omega, and integration property is 1 by j omega into I of j omega. We need I of omega is equal to, so I of omega is equal to, you take the common here, 1 plus j omega by the j omega is equal to, here also you take that 1 plus e power minus pi j omega whole divided by 1 plus j omega whole square. Okay, I of omega is equal to, cross multiply this, j omega 1 plus e power minus j pi into omega, cross multiply this is omega, and denominator will get 1 plus j omega whole square whole multiplied with 1 plus j omega. Okay, my dear students. Now, using these two equations, using this Fourier transformation of t and the Fourier transformation of this function, you get the I of omega is equal to, or inverse Fourier transformation you can apply directly. You'll get, see what we explained here, the sine t mu of t, a little bit wrong we got. Otherwise, you can see, we'll show the sine t mu of t. See here, x of t is equal to sine omega t. Sine omega t. What is the sine omega t saying here? X of t is a cos omega t is a 1 by t e power j omega t plus 1 by 2 e power minus j omega t. And one Fourier transformation is a 2 pi delta omega. By using here, it is a Fourier transformation. We'll get pi into delta of omega minus omega naught plus pi delta into omega plus omega. And sine omega naught, and this is a function pi j, pi by j into delta of omega minus omega naught minus delta of omega plus omega naught. This is a way you can find the Fourier transformation of sine and the cosine of omega naught into t. If it is multiplied with the mu of t, I will show that also. So in this slide, we don't have that one. See, remember that formula, that is a sine t mu of t. The sine t mu of t, the function, what we did, it's a little bit wrong we got here. Actually, the 2j omega at the 1 plus j omega whole square you have to get. Where we did wrong, e power jt, e power minus jt mu of t. Take the next one. But minus 1 by j omega into j into 1 minus omega. For the second one, e power See, we have here the 2j is there, my dear students. 2j. Sorry, here the 2j is there. Then e power minus jt mu of t. I'll find out that also. E power minus jt mu of t e power minus j omega into t dt. The integral value minus infinite to infinite. It becomes of integral 0 to infinite e power minus jt into e power minus j omega t dt. So e power minus j you can take as a common 1 plus omega into t dt. There's the integral 0 to infinite. So e power minus jt e power minus j omega. Apply the integral here, the e power minus j 1 plus omega into t by minus j 1 plus omega. Okay. As infinite and the 0. Infinite you can substitute 0 minus 1 by minus j into 1 plus omega, my dear students. So you got it is a minus of minus, here the minus and minus is a plus 1 by j into 1 plus omega. Okay. These are two terms we got, and 1 by 2j is also we have previously. 1 by 2j, because here next you can simplify the 1 by 2j, take the common here j square, here also the take the common is a 1 by j, the both the terms. One minus omega into 1 plus omega minus 1 plus omega and minus 1 minus omega 1 by 2j square minus 1 minus omega minus 1 plus omega whole divided by a plus b into a minus b, my dear students. 1 minus omega square okay, and here the 1 plus omega minus omega get cancelled, minus 2j minus not the 2j minus 2 by the 2j square into 1 minus omega square. 2 to get cancelled, and j square is a minus 1, minus also get cancelled. 1 by 1 minus omega square. And now I am replacing this function as because of j square is equal to minus 1. Okay, my dear students. So 1 by 1 minus 1 you can replace as a plus j square into omega square. Okay. Finally, we got 1 by 1 plus j omega whole square. Okay, is the right, my dear students. It will be strong. We are applying there. Here it is a j omega 1 by 2j is also there after simplifying. These are wrong. What we did here. The sine t. Okay, this is also wrong. For the first one, the Fourier transformation is minus 1 by j into 1 minus omega. For the second term, plus 1 by j 1 plus omega, and it is multiplied with the 2j 1 by 2j, my students. Simplify this function, and finally we got the 1 by 1 plus j omega whole square. Okay, the sine t mu of t. What is the Fourier transformation? Fourier transformation we got as 1 by 1 plus j omega whole square. If it is a step function is shifted with the pi samples, the second you see here. The second term, sine t mu of t, here is a 1 by 1 plus j omega whole square we got, and sine t mu of t minus pi 1 by 1 plus j omega whole square, and is multiplied with the e power minus j pi into omega. E power minus j pi into omega, my dear students. Since t is shifted with t minus pi, so e power minus j omega into pi for the second term. Got it, my dear students? Okay. You can find out any Fourier transformation for the given network signals. I explained the two in terms of the current is given, and you have to find out the voltage, and here the voltage is given, and you have to find out the current. Okay, my dear students. The next one is simple thing. Find the fundamental period of t. Find the fundamental period t, the fundamental frequency omega naught, and the Fourier series coefficients an and of the following periodic signals. These are Fourier series, my dear students. Okay. Always in the external examination, they given only the graphical representation. You have to find out either it is a Fourier series or the Fourier transform. How it is, simply you have to find out the fundamental period they're asking them. You can find the slope. Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. What is the y, my dear students, here? The y is x of t minus 0, and x is the t minus, you take the slope. Okay, we got the x of t is equal to minus t minus 2t plus 1. Minus 2t plus 1. This is a given signal. This is a given signal, my dear students. For this given signal, you can find an and the a0 and an, because they are asking that is a Fourier series coefficient of an. An is equal to, you have the formula is a 2 by 2 integral t1 to t2 or the t2 t plus t x of t cos n omega naught t. Where n is equal to 0, the a of 0 will got cos 0. Okay, and here the t is equal to 0. 1 into cos 0, the value is 0 only. Okay. Next thing, for the given periodic square wave, we can find out the Fourier series of these components also. Fourier series. The given x of t is equal to 1. X of t is equal to 1 from the variation of here, see, minus t by 4 and less than or equal to t by 4. Within this range, it is 1. And another one you can see here, minus 1 is also there, because the negative cycle, that is a range of minus t by 2 to the minus t by 4, or t by 4 to the t by 2, minus 1. Understood, my dear students? See, observe here, minus 1 is from the t by 4 less than or equal to t less than or equal to t by 2, and 1 is varies from the minus t by 4 to the t by 4. So I am taking from here to the up to minus t by 4 to the t by 2. Minus t by 4 to the t by 2. What the x of t? Then you can find the a naught, an, and the bn values to get it is a Fourier series components. Okay, it's a Fourier series, my students. Coming to the Fourier transformation. The Fourier transformation of the gated function. The given x of t is equal to a from the variation of minus t by to the t by 2. So x of j omega is equal to, or x of omega is equal to a into integral minus t by to the t by 2. A is varies from here. It's a 1 e power minus j omega t. You can apply the integral e power minus j omega t as e power minus j omega t by j omega. One time you can apply the upper limit t by 2 and the lower limit is a minus t by 2. Sine, I will explain here. Fourier transformation. Given it is a minus t by to the t by 2, the range a is a x of t and e power minus j omega t dt. Okay, my dear students. X of omega is equal to, okay, a into e power minus j omega t whole divided by minus j omega into t by 2 minus t by 2. That is equal to a by minus j omega whole multiply with the upper limit if I am taking e power minus j omega into t by 2 and lower limit you can take e power minus j omega into minus t by 2. Following a by minus j omega now it is a e power minus j omega t by 2 minus into minus plus minus students e power j omega t by 2. Okay, now I can multiply the minus j omega inside a into with the minus I am taking e power j omega t by 2 minus e power minus j omega t by 2. After multiplying the minus, this becomes a minus and this one is a plus. Whole divided by j omega. Okay. So multiply and divide with the 2. 2a by omega. 2a by omega is a 2 j e power j omega t by 2 minus e power minus j omega t by 2 whole divided by, here the j is there. Now I can multiply the 2 to get cancelled, j omega 1. So see, this is in the form of the sine function. 2a by omega and is a sine x. What is the x here? E power jx omega t by 2. Sine omega t by 2. Now it's got the same thing. 2a by omega sine omega t by 2. I would convert into the sinc function. Convert into the sinc function. Sine omega t by 2 here. Sine omega t by 2. Actually, the omega is nothing but 2 pi. Sinc function is sinc theta. Now we got the sinc theta is equal to sine pi theta by pi theta. Okay, my dear students. So in the denominator already omega is there. We need t by 2 as multiplied denominator and take it to the numerator also, t by 2. Okay, so 2a t and here the 2 is also there, t by 2, 2 to get cancelled, and I am taking the sine omega t by 2 and omega t by 2. Okay, my dear students. denominator and numerator, I am multiplying t by 2 and t by 2. 2a into t by 2. 2a into t by 2 to get cancelled. I multiply this omega here, sine omega t by 2 by omega t by 2. And in this function also, again, at is there already, at into omega sine 2 pi f into t by 2. Here the 2 to get cancelled, 2 to get cancelled, my students. Sine ft, okay, by, in the denominator also same thing, 2 pi f t by 2, 2 to get cancelled. So now it is in the form of sine pi f t. So pi with the theta here is the sinc theta. So at sinc ft. See here, sine x of f or x of j, x of omega, at into sinc ft. This is a Fourier transformation of the given gated function or the gate function, varies from the minus t by to the t by 2. Okay, my dear students. This is also very important for example, my dear students. 2, 3. Okay, some more examples are there remaining. The Fourier transformation. In the next class, the tomorrow class, we can see this. We completed the Fourier transformation of the gated function and Fourier transformation of this, and Fourier transformation of the given step functions, and Fourier transformation of the given graphical representation here. And if any function is given in the quadratic functions with the d square y of t by dt square plus 4 dy by dt, the linear constant coefficients are continuous time linear time invariant system. See here the CTLTIS means continuous time linear time invariant system characterized. If suppose a given function is a differential equation, in the differential equation, how we can find the Fourier transformation? That is also very important, my dear students. And if any signal is given in terms of a delta function, how we can find the Fourier transformation? You see these 4 examples in the tomorrow's class. Okay, my dear students, in the Wednesday class. Thank you. If any doubts is there, please rise. We practice, my dear students, every day. After listening this, you can practice. I have to note down when I am saying here, or you can take the screenshots, then you can practice, then only you can understood, my dear student. Otherwise, it is somewhat difficult to understood. Okay. Any doubts? Thank you and thank you.